Hi, everyone. Welcome to the Data Scientist podcast. I'm very happy to have here with us today Lina from EOS Data Analytics. Sorry, did I say this right?
Yes,
Or
DA, or it's fine. Yeah, data
okay,
analytics,
perfect.
right?
Yeah. So EOS Data Analytics is a company that deals with geospatial data, and which is a very interesting subject. I think it's an up-and-coming area, and I'm very happy to have Lina here with us today to talk about this subject. So, hi, Lina. Maybe you'd also like to introduce yourself. I guess you're probably going to make a better intro about yourself than I did.
No, it's fine. Hi, I'm Lina. I'm working as a director of customer success and account management at EOS DA. So I know a lot and pretty much everything about existing customers that we have and their challenges and goals and everything. So I am pretty aware of all the solutions that exist on the market, to suggest the best one. I'm making sure that the customers are satisfied with the services we provide, and we suggest them the best ever solutions. So yeah, I'm just taking care of customers in my company.
And I wanted to ask you, this space, geospatial data, where do the main applications lie? I know that agriculture is a big one. Are there any other industries, or is this the primary focus?
Yeah, right. So our company focuses on agriculture and forestry. We use satellite data to create, actionable insights for end users, like farmers or also other agriculture players, insurance, input suppliers, traders, and we transfer the satellite data together with ground truth data, from the fields, historical data, into understandable insights, so farmers can make decisions based on that, on this data. So our primary focus is agriculture and forestry at the moment.
I see. And which countries do you find they're adopting this technology? Where are there any countries which are ahead of the curve in using this type of data for agriculture than compared to others?
Yeah, I would say this is a global, case, because agriculture is popular everywhere because everyone needs to eat, and that's for sure. And so, but of course, the most developed market at the moment, and it's that adopting satellite technology and smart farming technology, is the US and Canadian market, Latin America, Brazil, Ecuador. They're acquiring, they just starting acquiring and adopting this technology, but also Europe.
Hello, can you hear me?
The industries there. So yeah, so everyone is trying to adopt this technology, smart farming technology, at the moment.
Okay, and what types of data are you dealing with? I guess image data must be one, but are there other types of data you can extract using this technology?
Yeah, right. So I think it's first of all, it's worth mentioning that satellite, satellite data plays indirect role in kind of tackling climate change or driving agricultural or forestry sector to sustainability or just to progress. So we should understand satellite data is more about showing the direction. And saying this, I mean that we cannot exclude human reason from this equation. People are the ones who make the decisions on this data, and main purpose of satellites is to provide reliable and frequent data as we can. And we should consider that satellites at the moment are the most scalable solution that provides us with global picture, helicopter view, because previously, when you were a farmer, you can only make decisions and collect data on the local scale, at the local scale. So you just what you can analyze with your eye, your eye spectrum analysis, I call it. Yeah. And at the moment, satellites and drones and sensors that appear, they bring us definitely to a new level, and they create a global community where every player, from a small farmer to a big food production companies and traders, they can be linked together in like bigger picture and better understand their impact. So yeah, if talking about like the data that we provide is like, first of all, this is definitely like the imagery, and with the upcoming satellite launch that will happen like this year, EOS Sat, we're going to provide like better quality, higher resolution, up to 3-meter resolution imagery is with better frequency that will help us to know more about like crop state, the health of the crops, about like vegetation indices, and spot some dramatical changes in the field like on time and react to them accordingly. And also will be better understanding the productivity of the fields, like considering that there are many factors like soil erosion that impact like yield and weather conditions, and it will help us like to get like fast and like quick imagery that if something is changing on the field. Also we'll be able to access like weather risks by checking like weather forecast and historical weather analytics. And this is something that will help us to model, you know, unpredicted scenarios and like that are likely to happen. I mean, in terms like unpredicted weather conditions that might happen, and develop an action plan in case they happen, because you cannot, you know, rule the weather, but you can predict, you can plan. So, and also satellite imagery, they help to track the result of fertilizer usage and seeds. And you can compare, you know, the performance of different hybrids, of different type of fertilizers, and like improve their quality. And besides, it's something that helps you to control how much fertilizers you use on the field, and also align it, you know, with the sustainability goals that like proclaimed around the world and everyone knows about them. So it's like in a nutshell, what data we get from the satellites.
I see. And how does this help drive profitability?
Yeah, this is like very good question. First of all, I would say that our company at the moment, there are 2 ways, you know, we can do this. There are like 2 ways USDA encourages agricultural market to adopt satellite technologies and subsequently like improve and boost their business. We suggest like partner programs for those companies who are interested in opportunities and for those companies that see that the future stands behind satellites. And we offer like making this more with like less impact. And we're trying to partner in with these companies. We suggest them out of box platform like that allows to analyze fields and their productivity like almost like near in real time, so they don't need to spend like money and resources to develop their own tools, because we already developed this. There is no reason, like, you know, to invent a wheel again if you can like get this technology and start using them for your clients if you're closer to them. Because of course, like being located like, you know, in specific area, you cannot just promote your technology in the Brazilian market and Canadian, and then you have to find partners. And we suggest technology. We suggest out-of-box solution that allows to monitor your crop health and like manage your fertilizer activities and everything. And another thing, like of course, like we develop we have developed a tool platform that like in real time processes the image, so you can access it from any part of the world. You just add your field and you start getting insights on your field. First of all, you can get 5 years of historical data, like what was happening back then. So like even like if we're thinking about like 30 years ago, those were like, you know, journals, manual written journals where you can get some historical data. And now with the satellite imagery, historical data is actionable. You can actually use it. You can access it, and based on that, you can make some predictions, planning. You can see how the productivity. You can assess the productivity of one field or thousands of fields. So then you can spot, if something dramatically happens on your field, you can react it within 1 day or 2 days and send your scout or managers to the field and fix it. Also with this platform, you can have a better, smarter fertilizer management strategy. I mean, if your field, is not productive, the productivity of the field can be different, and one part of your field can give you 10 tons per hectare, another part of your field can give you 2 tons per hectare, and it means that the fertilizers that you apply, the amount of fertilizer that you apply, they vary. So, and the platform helps you understand what amount of fertilizer to apply to this part of field, to another part of field, and that's how you save money. You don't overuse fertilizers, and this is actually how you save, and how you your yield is getting better with that.
I see. And do you find that it's possible to do predictive analytics with this kind of data, as in, not only predict the weather, but how far ahead into the future can you make predictions for, I don't know, the yield of a crop and things like that?
The thing is, of course, with the satellite data, and considering it as a scalable solution, so you can get the data all over the world. And of course, at the moment, the most valuable and trustful source of data is ground truth data, but it's really expensive. Still, when we do some predictions, when we do crop classification, kind of using machine learning technique or artificial intelligence, to identify what kind of crop is growing here, or to predict the amount of yield that will happen next year. We use both satellite data and historical data, historical statistics from the previous years, and of course ground truth data from field. Actually, so this is something that enriches your research. But if talking about prediction at the moment, usually customers ask for this year, for upcoming year, if you're talking about the yield prediction, upcoming season. And the thing is prior to the yield you can predict, the better, the higher value of this prediction is. And at the moment, the scientific society is actually lacking the data. And if you ask any scientist, they will tell you, okay, we need more and more and more data to improve the quality of the prediction, the accuracy.
Hello, can you hear me?
Yeah, right.
Sorry, you paused for a second. Yeah, go ahead. Sorry.
I'm saying that's why we're launching the satellite, in order to get more data, to make predictions more accurate. At the moment, depending on what kind of crop you are predicting, I mean, corn, wheat, soybean, or grape, for example, the models can be different, but the accuracy that you get it can be something between 60 to 90% of accuracy of prediction. And to improve this accuracy, we need more data. So if we're talking about agriculture, answering the question, it's usually one season ahead. But another thing that another doors that we get open here is modeling. You can model different complex virtual scenarios. So kind of, if you can imagine virtual farm, and applying thousands of variables, you can get different scenarios. I mean, by variables, I mean different weather data, unpredicted weather and predict like some weather disasters or something, soil type, different management technique, like how much fertilizers do you apply, seeds. So if you put this data into the model, you can model like hundreds, I don't know, of different scenarios. And that's how you will know how to act in case one of these scenarios is like likely to happen. So this is where agricultural community and AgTech, as we call it, is moving at the moment, you know, to get support decision systems that will allow you to get like virtual farm and model different scenarios for better decision making. And in some cases, you even don't have to go into the field to make decisions.
And where do you think the future of this area lies? Like, what are we going to see over the next 2, 3, 5, even 10 years?
Well, this is a good question, because for a satellite technology, it's like 5, 10 years is like very short term. But if you're talking about like satellite market, what we can see and what is happening at the moment, many companies, around like 20 companies at the moment are getting ready to launch non-geostationary satellites. This is like small cubes or something, small satellites. And they consist of several, the constellation might consist of several satellites, and they all dedicated to specific purposes. What you can see before, like the Landsat, MODIS, they were like launched. Sentinel, like the most popular, you know, open source satellites, they were launched for different purposes. And at the moment, the satellites that are going to be launched, they're like designed for specific purposes, because society understands that we need more data for specific industries, like for agriculture, forestry, oil and gas, mining, and everything. And those satellites should have different sensors, different bands that can collect different data for specific purposes. This is about like space industry. But if talking about like value added services, that's where like AgTech companies work. And so those that transform this satellite data into understandable insights for farmers and food suppliers and others. I would say that the future stands for those virtual farms, virtual support like decision systems, where you can like the players of agri market, they want to pay for like quick insights, because there is direct dependency between the frequency of the data and the quality of the data and decision that you make. So the faster we can deliver data to the market and make it understandable for decision making, this is the way we can improve the quality of the food, the quality of food production, yield, and everything. So at the moment, value-added services, they're working on collecting data and make it like with machine learning and artificial intelligence and other like solutions to make it actionable and deliver it faster to the market and the end user.
And do you find that maybe in the future there's going to be more open source data on that front?
Actually, yeah, definitely. So what is happening right now, you cannot ignore like the globalization process, and the community tends to share data, and you can find statistical data already open, and data from like open source satellites. And I think the future stands behind the contribution. Those companies that launch their small satellites and will be collecting data, one day they will become open. That's for sure. Because this is like we're working for the sake of like for the humanity and sustainable future.
Yeah, that's very interesting, because I think that since agriculture is something that concerns like everyone pretty much, I definitely see very large potential in open data around this. I know there are many countries, cities that try to open up their data for all kinds of purposes, so like crime, pollution, this, that. So I definitely see, sorry, a very high potential in agriculture for that. So that's cool. I think we probably have to wrap up soon, but it was a pleasure talking with you and hearing what you guys are doing. So if someone wants to learn more about the company, where should they go? And if they want to learn more about the subject in general?
They can go to our website, like EOS.com, and we have blog where we publish interesting articles about space, about agriculture, also LinkedIn, Twitter, Facebook, everywhere. We're pretty open and sharing like the knowledge that we're getting with the team of scientists, researchers, and developers. So we're pretty independent in that. So we're starting like from the very scratch, from the research, and then convert that into tools and platform.
Okay, perfect. Excellent. So thank you. And thanks everyone for staying here with us. Make sure to visit datascientist.com for more content on data science, AI, and blockchain. Thank you, Lina. Bye.
Thank you. Bye.